Today, we're continuing with 4.6 quadratic form and discriminant, but mainly focus on word problems. Now, even though the title says that quadratic form, meaning there will be some word problems where you will have to use the quadratic formula. Sometimes we may have to use part of the properties what we cover in 4.1, and you will see with this given example. In this word problem, a ball is bounced on the ground and into the air with initial speed of 64 feet per second. The projectile motion of the ball can be modeled by the function h of t equals 64t plus 3 minus 16t squared, where h of t is the height. What is the maximum height of the ball in the air? Alright, so what we do is underline this function, and it asks you for the maximum height. So this, again, is what we cover in 4.1. So in order to find maximum height, you would first need to find the x-coordinate of the vertex, because maximum height will be a parabola like this, where it's going to be in the middle of the function. So that means we're going to have to find the x-coordinate of the vertex. So x-coordinate of vertex. So even though I said x-coordinate of vertex, we will be working in the variable t. So the formula was x equals negative b over 2a. So in this case, it's going to be t equals negative b over 2a instead of x. Now, we have a function 64t plus 3 minus 16t squared. We first have to put it in order, a, b, c. So h of t equals the one with the t squared. That's where the a will be. So I'm going to put negative 16 t squared. And then where t is by itself is going to be plus 64 t and then plus 3. So this is my a, this is my b, and this is my c. So from there, I'm going to plug it in. So it's going to be negative 64 over my 2a, which is 2 times negative 16. So it'll be negative 64 divided by negative 32. Well, negative 64 divided by negative 32 is positive 2. So my t will equal to 2. Alright, once you find your t, or as I stated in 4.1 x, in order to find the y, or the h of t, simply plug in the value of the variable t. So I'm going to plug in 2 into this function, or you can plug into this function where it's in order. Doesn't matter, but say I use the original. So h of 2 is equal to 64. So there's t, so I'm going to put in 2, and then plus 3 minus 16, and then there's t squared, so I'm going to put 2 with the square. So once that is in, then you're just going to simplify using PEMDAS. So I'm going to do the exponent first. So this will stay the same. But t2 squared will be 4. Alright, and then I'm going to multiply. So this will be 64 times 2, 128, plus 3. Negative 16 times 4, well, that's going to be minus 64. Alright, 128 plus 3, that's going to be 131 minus 64. 131 minus 64, that would be 67. So my maximum height is 67 feet. So that's the maximum height that the ball bounced up to before coming back to the ground. So maximum height, again, is at the top of the parabola. So that's where it will reach to its maximum height and then start coming down. So my answer is maximum height 67 feet. So to review, we did the same process as 4.1, finding the x-coordinate of the vertex, but instead of using the variable x, we used the variable t. But the process was the same. Using the formula, negative b over 2a, we found a value which, instead of saying x equals to 2, we said t equals to 2 because that's the one we're working in. And in order to find the height, which is the y-coordinate of the vertex, in this case, h of t. So again, when I'm talking about x-coordinate of the vertex, the maximum height is the y-coordinate of the vertex. But in this problem, instead of x, we're using t, and for y, we're using the h of t. And then when we plug it in, simplify using PEMDAS, we got 67. Maximum height equals 67 feet.